So hi everyone. Today we're kicking off Penn's Power Corner. I'm your host, Aalyia Shaukat, and I'm here with Andrea Estrada-Hein, Vice President of ABB's Switchgear Business. Andrea, very glad to have you here.
Thank you for having me. I'm super excited about this talk.
Thank you. So let's talk about Europe's recent move to prohibit sulfur hexafluoride, or SF6, from medium voltage switchgear. Why is this the case?
Well, SF6 gas has been used in the past because it has superior performance in terms of isolation, right? So it's like the perfect gas for medium voltage switch gears to be used and interrupt current, because that's what we do, right, in the switch gear. But it happens that although it's not toxic, it's safe to use, it's technically superior to any other gas, it has a huge global warming potential, like 24,000 times more than CO2. That's why Europe has gone that step forward and decided to stop it, because although in the use there are very almost no leakages by filling it in at the beginning and end of life, it could be a risk for climate change, and that's why the move has been made.
Okay. Oh, thank you for that. So what insulating medium is ABB using as the alternative, and how does it compare to other alternatives?
So we've decided to use dry air, and dry air is like the air we breathe right now, but it's been taken, like all the water has been taken out. That's what it's called, dry air. So it has no humidity to help with interrupting the currents. And the problem with dry air is, and that's why SF6 was used, being an insulated medium, is that you can use it, but you would need more space. So in terms of having the same footprint, which was one of the important things for us, we had to move to higher pressures in the tank. So that's one of the main differences. And some of our competitors have put already a little bit of mix of CO2 also in the gas medium. We have decided not to do that because we're going away from SF6 to avoid CO2. So we've gone with a pure dry air mix.
Okay. I know there was a 7-year development cycle, right, to develop this SF6 free medium voltage fleet, right? What can you talk about some of the design challenges that occurred during the design cycle? Things that ABB had to kind of overcome.
Of course, and I think, and this is what we discussed with the team, this is an unprecedented technological change. I mean, we are in an industry that's very conservative, that's lived from incremental innovation over the past years or decades, actually. And now having to change away from SF6 free, I think it gives us engineers a great opportunity for innovation. So it's actually been a positive challenge from that side. And we've been able to experiment with things that were not common to us. But that brings challenges, right? When we try something new, not everything works according to plan. That's why it also maybe took a little bit longer than we were planning in some parts, but still has been a great challenge to, I think, once in a lifetime opportunity for our engineers who are working on this problem right now. One of the things we had to deal with is, as I was explaining before, if we want to have the same footprint, we need to have higher pressures. That means that the mechanical design had to be changed and be it conform to be able to deal with higher pressures in the tank. So from the mechanical design, we had to try new things. Then also air in comparison to SF6 free, SF6 has a lower thermal conductivity. So we had to deal with that and do a lot of testing for heat dissipation, and we had to really work from a chemical standpoint on different versions and mixes of the air. So that was also one of the challenges we had. And air, in comparison to SF6, oxidizes, right? So we had to also start using silver coatings, which we had not used that profoundly before, to avoid that the insides of the switchgear start oxidating with air when it goes into function.
Thank you. Okay. Maybe we could talk about the performance metrics of SF6 free switchgear compared to traditional SF6 units in terms of, let's say, reliability, footprint, and maintenance.
So all three should stay the same, right? So reliability, maintenance, and footprint, that was our motto on how we want to launch the new product lines. And we want to have everything what the customers know about a switchgears. So we have the same footprint, same look and feel, same maintenance, same reliability. That's what we're promising out. The slight difference will be in the capex, so the cost of purchasing the switchgears, because we require new materials, be it more silver, different vacuum interrupters and circuit breakers, which were bigger, and of course more steel to be able to contain the higher pressures. The material cost of the switchgears are higher than the old SF6 switchgears. So that's the difference that we see, not on the operating side, but on the initial purchasing side. And the difference of how much it would be, like how much higher cost we would have, it would depend on the configuration of the switchgear. If it's a very simple switchgear, then of course, relatively, the material costs will have a higher impact. If it's a very advanced switchgear with a lot of features, then this extra material cost will make a smaller difference. But that's the main difference that we see right now. And we're in a big innovating cycle, so of course we're working on reducing this cost and trying to go back to baseline as fast as possible.
Yeah, that was actually going to be my next question about price parity. How are you looking towards reducing the costs and reaching parity with some of the traditional gear?
So we've been pretty busy right now on launching the different product lines.
Yeah.
And I mean, what we see is utilities have their own portfolios, and these things have evolved over decades, right? So they're like very specific, tailor-made for each country, for each city. So we're trying to catch up with that to be able to offer our customers the same breadth on the portfolio that we're used to offering. So that's our priority number one. And in parallel, we're after the launching is stable, then we are planning on looking at how we're going to improve the design. What are we learning from what it's being launched, and build that back into the loop, of course, to reduce material costs.
Okay. Actually, can we talk about if an example of how it's tailor-made for each city, if you don't mind getting into a little bit of detail about that?
Yeah, well, there's no, of course not. But there are different. It ranges from everything. It ranges from like the design, like the single line diagrams are different, and the setup of the whole switchgear is it's different. It could be very complex or very easy. So that's one, like how they are set up. But also, there are differences of like where the buttons need to go, so that the service people of our utilities, of our customers, they're always having the same look and feel. And so it could range from the color, it could range from the positioning of certain buttons and opening doors and things. So it really ranged from really like the technicals to the look and feel of the switchgear.
Okay. Kind of moving forward, future focus. Are utilities proactively seeking solutions beyond the regulated 24 kilovolt threshold? Are there technical barriers at sort of higher voltages?
We're working on technical variants for high voltage because, of course, starting 2030, we will have to introduce the higher voltage switchgear. So that will be mandated by law. And at the moment, we are working with a couple of customers to pair up and start discussing how these new designs will look like. We're already working on them, of course, to be able to launch them in 2030. So it looks like it's far away, but it's really around the corner when it comes to product development. So we have paired up with well-known customers to start looking at the new designs and new products and doing some prototyping and testing with them. So it is a few, because there's some that don't have the breadth with also to take in these innovations, and the ones that do are the ones that we're working with right now.
Okay.
But I think it'll take some time. I don't think there's a need to adapt so fast, because they still need to adapt the 24 right now. So I think that keeps them busy right now.
And I guess what voltage, you said in 2030 regulations are moving towards higher voltages, right?
Yeah, starting 36 kV.
Oh, okay. How many kV? Sorry, I didn't catch that.
36, sorry.
36, starting 36
yes.
kV. Okay. Well, I mean, let me know if is there anything that I might have missed that that I didn't address in terms of questions. Just let me know if there was anything that.
No, I think we covered like all the important stuff. Just maybe
Yeah,
to say again that it's been quite a ride
it's
to
been
do
quite a ride.
this shift, and it's been, I think, a really once in a lifetime opportunity for engineers working on this. And despite the challenges, we're thrilled to work with our customers and utilities to make this happen and to bring this change forward and thus help the environment.
Yeah.
Yes.
Thank you so much, Andrea. I really appreciate your time. You know,
Thank you
I'm
so much.
excited. I'm excited to see what ABB does next in modernizing the European utility infrastructure. This is all very exciting stuff.
Yes, me
Thank
too.
you. Thank you.
Thank you. Thank you for your time.